Pitch control is achieved through two hydraulically powered elevators and a hydraulically powered stabilizer trim system. Elevator operation. Moving either control column operates a dual set of cables that lead to hydraulic actuators on the elevators. There are 3 actuators for each elevator, 1 for each hydraulic system. As long as at least one hydraulic system is functional, elevator operation is assured. A column override system located between the 2 control columns allows a jammed control column to be overridden by movement of the other column. A fairly high force is required to break free of the override mechanism. Movement of the free column is then transmitted through its cable system to the associated actuators. At the elevator end of the cable system is another override mechanism that essentially performs the same as the column override system. This override mechanism allows separate deflection of an elevator surface in case one elevator becomes jammed. Elevator deflection is shown on the ICAS status page with dual pointers, one for each elevator. Full-scale pointer displacement corresponds to full elevator deflection. Elevator feel force, artificially generated, is supplied by 2 elevator feel computers that operate with left and center hydraulic pressure. These computers modify the elevator feel depending on airspeed. Note, one elevator feel computer is sufficient to generate elevator feel. Mechanical springs provide false elevator feel if left and center hydraulic pressure is lost. Stabilizer trim operation. Stabilizer trim operation depends on hydraulic power from the left and center hydraulic systems. Normally, both hydraulic systems are used together. Two trim control modules control stabilizer operation. The trim control modules receive the stabilizer trim commands and therefore control hydraulic power to the hydraulic trim motors and hydraulic brakes. Two red-guarded switches, the stabilizer trim cutout switches, control the hydraulic power to the trim control modules. With the guards closed, the switches are in the normal position and hydraulic power from the left hydraulic system and center hydraulic system is available for stabilizer trim operation. Placing a cutout switch in the cutout position removes the respective hydraulic power from the associated trim control module and trim motor. Therefore, if both switches are in cutout, No stabilizer trim is available. There are 3 modes of stabilizer trim control: electric, automatic, and alternate. All 3 trim modes require hydraulic pressure. Inputs for each control method are highlighted on this frame. All 3 trim modes use elevator field computer pressure to control the rate of trim as a function of airspeed. As airspeed increases, trim actuator movement decreases. Stabilizer position indicators are located on both sides of the control stand. The indicators show stabilizer position in units of trim. The green bands on the indicator scale show the takeoff trim range. An off flag appears in the trim indicator when electrical power is removed. The electric system consists of split trim switches located on the aileron control wheels. Activating both switches together on either control wheel sends an electric arming and directional signal to both stabilizer trim control modules. In turn, the trim control modules use hydraulic power to move the stabilizer. Moving only one of the 2 switches applies hydraulic power but does not release the brakes, while the other switch releases the brakes but does not apply hydraulic power to move the stabilizer. Therefore, both switches must be moved together and in the same direction. The trim control modules vary the rate of trim as a function of airspeed. As the speed increases, the trim rate decreases. If the control columns are moved in a direction opposing the trim operation, the control column switches will interrupt the electric trim signal. This feature can be used to quickly arrest an electric trim runaway. To complete our discussion of electric trim, let's describe the effect of its operation on the autopilot. Use of electric trim during single autopilot operation will cause the autopilot to disconnect. However, with more than one autopilot engaged, such as during approach, the electric trim operation is inhibited. The alternate trim system serves as a backup stabilizer trim system. The alternate trim switches override all other stabilizer trim inputs. Like the electric trim switches, moving both switches provides electric arming and directional trim control signals to both trim modules. One important thing to remember is that the alternate trim overrides the electric and automatic autopilot trim. Additionally, the alternate trim signals bypass the control column switches and will activate the alternate trim regardless of the control column's position. As with all stabilizer trim on this aircraft, the alternate trim requires hydraulic pressure and will not operate if both trim cutout switches are in the cutout position. Finally, alternate trim action will not cause the autopilot to disconnect. However, an unscheduled stabilizer trim light will come on if alternate trim is activated when an autopilot is engaged. The engaged autopilot provides automatic stabilizer trim. Automatic trim uses only one trim control module and trims at only 1/2 the electric trim rate. Autopilot trim is available whenever an autopilot is engaged in the command mode. The control column switches will interrupt electric trim or automatic trim operation if the control column is moved in a direction opposing the trim motion. As with all stabilizer trim on this aircraft, the automatic trim requires hydraulic pressure and will not operate if both trim cutout switches are in the cutout position. The 767 is equipped with a Pitch Enhancement System, or PES. PES provides limited stabilizer trim control in the event of a failure of the left and center hydraulic systems. The Pitch Enhancement System consists of a power transfer unit, motor pump. This PTU uses right hydraulic system pressure and trapped left hydraulic system trim fluid to provide a backup trim system. The PES automatically activates if both left and center hydraulic systems fail in flight. The PES makes stabilizer trim available at 1/4 of the normal trim rate and can only be operated by use of the electric trim switches. The alternate and automatic trim systems cannot operate the PES trim. If only one autopilot is engaged, use of the electric trim causes the autopilot to disengage. If 2 or 3 autopilots are engaged, electric trim is inhibited. alternate trim action merely overrides all other trim inputs, but does not disengage an autopilot or autopilots. Uncommanded stabilizer trim operation will cause the overhead panel unscheduled stabilizer trim light to come on and an ICAS caution message of unscheduled stabilizer trim to appear along with the aural beeper. The light, beeper, and the caution message may appear for these different reasons: uncommanded stabilizer movement, stabilizer moving in direction opposite to elevator input with AP engaged, use of alternate trim switches with autopilot engaged. Except for alternate trim operation, uncommanded stabilizer trimming can be stopped by moving either control column in the opposite direction of the trim movement. This action opens the control column switches and interrupts electric and automatic trim inputs to the trim control modules. During electric trim operation, if the stabilizer is trimming at half the normal rate, the overhead panel stabilizer trim light illuminates, and an ICAS advisory message of stabilizer trim is displayed. This condition would likely occur because of a dragging break in one of the trim modules, a failed or inoperable trim module, or faulty circuitry to the trim module from the electric trim switches. Depending on which component has failed, full trim rates may be available through the alternate trim system if the malfunction is confined to the circuitry of the electric trim system.